Come to David 7 Sons Theater. You can contact us at David 7 Sons Theater at gmail.com. Okay, so this you can get us. Today, I want to teach you about the cytoskeleton and molecular motors. Okay, and I'm not going to talk about a lot about molecular motors, but I'm going to give you the basics you need for you to know something about molecular motors. Okay. So David 7 Science Theater is the best channel you can join and have all the science. Subscribe to our videos. Don't forget to subscribe. Click that bell for more and better videos. Like our videos, comment and share. Okay. So let's continue. If you look at this cytoskeleton, it shows various proteins. Okay. And the cytoskeleton, if we have the cytoplasm, then the cytoplasm will have a liquid part, which will be the cytosol, and that it has also a part which is not so liquid, and this part is towards it lies just beneath the cell membrane. So this part is called the cytoskeleton, and it is just component of several proteins. We have proteins, a lot of them, forming fibers, which fibers are forming the cytoskeleton. So these fibers, as you can see, a lot of proteins. Now you can see we have tropomyosin, like tropomodulin, adenosine. This is the cell membrane I've been talking about. Then we have anion exchangers. These are transmembrane proteins. Then we have ankyrin, which anchors these fibers to the proteins of the cell membrane. Have the beta chain, alpha chain, spectrins. Okay, these spectrins are very important in red blood cells. If they get damaged, then you get hemolysis of red blood cells. Okay, then we have glycophorins. Those are transmembrane proteins. By these other proteins here, as you can see, they are denoting proteins of the cytoskeleton. All right, let's continue. So the cytoskeleton is a complex network of fibers that maintains the structure of the cell and allows it to change shape and move. In some cells which are capable of moving, the cytoskeleton plays an important role. Changing of shape is also performed by the cytoskeleton components. And the cytoskeleton majorly includes the microtubules whose diameter is around 25 nanometers, intermediate filaments whose diameter is around 10 nanometers. Then we have microfilaments, the smallest, whose diameter is between 6 and 8. Some say 7, 6, 8, around there. So microfilaments are the smallest in diameter. And if we start with microtubules, these are long hollow tubular structures without limiting membrane. They are about 25 nanometers in diameter. We have seen that. And they are made up of two globular protein subunits, that is alpha and beta tubulin. The bundles of tubulin give structure strength to these cells. Okay, so bundles of tubulin, they are giving structure strength to the cells. And the microtubules form a transport system of the cell. Some of the other organelles and protein molecules move to different parts of the cell through microtubules. So, being tubules of this diameter, there are some proteins which are capable of traversing their lumens and they go to other parts of the cell. Okay. So, if we talk more about microtubules, we have kinesin and adenine. These are molecular motors. They help in movement of molecules through the microtubules. So if some molecules are going through the microtubules, these two molecular motors play a very important role for these molecules to traverse through the lumen of the microtubules. Then you have the cilia and flagella, which project from surface of certain cells. Of course, we have cilia on spermatozoa, cells of the respiratory mucosa. We have cilia on the fallopian tubes. So the cilia and flagella are also composed of microtubules. enclosed in the plasma membrane and are active in the locomotion of cells. And flagella are also composed of microtubules, which are enclosed in the plasma membrane and are active in the locomotion of the cells. We said the microtubules lack a limiting membrane. So now here they are enclosed to form cilia and flagella. I was saying that cilia are very important in respiratory mucosa. When some debris enters into the trachea, then this is brought back to the mouth or nose by using the cilia. It is brought back to the esophagus where it can be swallowed. Then gastric juice will destroy those bacteria. Okay, so let's continue. All right. So if you look at this, we have cytoskeleton fibers. We have the microtubules, whose diameter I mentioned. We have the actin filaments, which are the smallest in diameter, 7 nanometers. Then we have intermediate filaments. You can see these are 10 nanometers in diameter. So let's continue. The intermediate filaments are filamentous structures of that diameter, and some of these filaments connect the nuclear membrane to the cell membrane. We have the membrane surrounding the nucleus, so it can be connected to the membrane of the cell using these intermediate filaments. And their main function is to mechanically integrate the cell organelles within the cytoplasm. So these are physical bondages, physical links which are between different organelles of the cell, okay? And if they are absent, cells will rupture more easily. And when they are abnormal in humans, you'll find the skin having blisters, okay? That's how we see that the microtubules, the intermediate filaments, are damaged. Let's talk about microfilaments. The microfilaments are long, solid filamentous structures having a diameter of 6 to 8. These are the smallest. And they are made up of majorly contractile proteins, which we know as actin and myosin. And the actin is the most abundant protein in mammalian cell. Actin attaches to various parts of the cytoplasm by other proteins, anchor proteins, for example, ankyrin, okay? And the microfilaments, as you can see this, have actin, we have myosin, just as you see them here, actin and myosin, okay? So these are microfilaments. These are the examples you can give if they ask. Say diameter is about 6 to 8, 7, something like that, but in nanometers, okay? And the microfilaments, if I continue to talk more about them, the extension of microfilaments along with the plasma membrane on the surface of the cell will form microvilli. So now you can see the cilia and flagella were being formed by microtubules, but now the microvilli is being formed by microfilaments, which increase the absorptive surface of the cells. For example, in intestinal epithelium, we have microvilli. Microvilli and stereocilia are not formed by microtubules, but they are formed by actin, call it microfilaments, okay? So they increase the absorptive surface of the cells. Now we have the skeletal muscle. The skeletal muscle, presence of actin and myosin filaments is responsible for their contractile property. Muscles are capable of contracting because we have the microfilaments present, which later form sarcomeres, which sarcomeres will expand or reduce to cause contraction of the muscle, okay? Now, return to molecular motors. So we've seen the microfilaments are important in contraction of muscles and also absorption, okay, because they increase the absorptive surface area. Okay, so molecular motors help in movement of different proteins organelles, and other cell parts. These are cargoes or cargo. These are cargo to all parts of the cell. This can be divided into two types. Molecular motors, we have those which are based on microtubules, and we have molecular motors which are based on microfilament, call it actin. So you have actin-based and microtubule-based molecular motors. So if we start with microtubule-based molecular motors, this is a superfamily of molecular motors that produce motion along microtubules. And the two important molecular motors we know have conventional kinesin and dianesis. These are causing motion along microtubules, okay? Kinesin, dianesis, okay? And we have actin-based molecular motors. The actin-based molecular motors are, this is a superfamily that produce motion along actin, okay? So molecules move along actin. And the important example of this kind is myosin. Myosin is an actin-based molecular motor. Okay. So thanks for subscribing. Thanks for watching our videos. We wish you well. Okay. Thank you for following the David7 Science Theater. Comment below for any consultation. Just text at gmail.com David7 Science Theater.